So in discussing hypothesis testing, we need to discuss directionality. Now, I want to say this up front, that this issue I feel is not as important as some people will give effort to prove it. But in your operations classes especially, you'll find that directionality is emphasized. So we need to determine what the direction of the test is before we test the null hypothesis. And in this way, the test can either be a one-tailed or a two-tailed test. For example, a one-tailed test would assume that we want to know if it's greater or less than. So in the last case that we were discussing in the last segment, if the person is innocent, we really don't care how innocent the person is. We just want to know if the person is less than some critical amount. In a one-tailed test, or excuse me, in a two-tailed test, we don't care if the person is innocent or guilty. We want to know if it has both directions. It's more than or less than. So we'll discuss both of these with an example. The first example is a cereal manufacturer is concerned that machinery is not producing the weight listed on the package. So this is a bidirectional or two-directional test. I don't really care if it's more or less. I just want to know if it's different than what is stated on the package. So we use a two-tailed test in this case when the question does not have a directional implication. It is interesting to know if the actual mean is lower or higher than the hypothesized mean, but that's not the purpose of the test. We want to know, is it different than the hypothesized mean? So we ask, is there enough evidence for the manufacturer to believe that something is wrong with the mean ounces and the equipment should be taken offline? This is a non-directional test. The actual mean could be either greater or less. So we would state the null hypothesis H0 or H0 as the population mean equals 32 or 32 ounces. Okay, and I want you to think about why this would be a logical null hypothesis. We're stating the status quo. We have to start with the assumption that it is 32 ounces unless we have evidence that it is something other than 32 ounces. Now in a bidirectional test, H1 or HA, a hypothesis, alternative hypothesis, is that the mean does not equal 32 ounces. So in this case, we would draw this curve, but we could say that at some point, we would reject the null hypothesis. So somewhere beyond, and we'll start with the assumption of about 2 standard errors from the mean, we would say that, oh, this process really is more than or less than 32 ounces. Anywhere in this range right here, we'd attribute the differences to nothing more than sampling error. Sampling error is the natural variation that we would expect when we're drawing a sample from a population. Let's look at a one-dimensional or one-directional test. So in a one-directional test, we care whether the machine is filling more or filling less. So, for example, if we were more concerned with the fact that it was filling or overfilling, so maybe from the manufacturer's point of view, they don't want to overfill the boxes, then we'd assume that the mean weight is 32 and test if it is greater than 32. So the null hypothesis is 32 ounces or less. We really don't care if it's filling up at 28 or 25 or 22 ounces. We just don't want to overfill. So our alternative is that the mean is greater than 32 ounces. This is what we are trying to show. So the alpha, or the probability of a type 1 error, would be focused on the right-hand side. Now, if the manufacturer wants to know if the machinery is underfilling the boxes, so maybe from the customer's point of view, you wouldn't want to buy 32 ounces and really get something less than that. Then this directional test would assume that the weight is 32 ounces or more, and it's testing if it's less than 32 ounces. So now the alpha, or probability of a type 1 error, is on the left-hand side. Now in your quizzes and in other courses, this directionality is going to be important. However, in most of the problems that I give in this class, I'm going to word it in such a way that directionality is really not important. We'll use a two-tailed t-test. And there's several reasons for doing this. Probably the primary reason is that when you use a two-tailed t-test, you're going to be more conservative. This means that there's a lower probability that you are going to reject a true null hypothesis, which is making an alpha error or a type 1 error.